Hello friends, welcome to my channel, The Invisible Maths Teacher. Today I'm here in front of you with the second chapter of class 10th, that is circles. So let me give you a brief introduction about circles. Okay, so let us proceed. Here I have shown you three circles. Okay, so here we know this is the center of the circle. Okay, center of the circle, and if you just draw a line from this center to any point on the circle, we call this one as radius of the circle. And if you extend that line backward also like this, here again we will have one more r, that is radius of the circle. So I can say this is one r and this is another radius. So if you join together, we will get the total diameter of the circle. So here I can say diameter is equal to 2 times r. Now coming to second circle, again this is the center of the circle, and if I am drawing a line like this, okay, that is 2 points on the circle are joined, then we call this line as chord. If if 2 points on a circle are joined to form a line inside the circle, then we call that line as chord of the circle. So all these things are chord. I'll show you. You can say all these lines are chord. This is a chord. Wherever you draw, or whatever points you take on the circle, whatever 2 points you take on the circle, all are chords of the circle. But you can see here with my blue color, you can see here this one is one chord. I can say A, B, C. Okay, AC is a chord, AD is a chord, then EF, this line is a chord, then XY, this is also chord. But what about this one, Z? Okay, what is this AZ? Yes, AZ is also a chord, because these two are points on the circle. A is a point on the circle and Z is also a point on the circle, and if you just join that line is inside the circle, so we can call that line as the chord, and hence this is a diameter also, as the line is passing through the center of the circle. You can see it is passing through the center of the circle, so hence it is a diameter of the circle. So I can say diameter is the longest chord. Okay, now coming to next one, coming to this one. Here you have a circle here. If I'm just taking a small portion of the circle like this, okay, hope you can see this one. It's just a small portion, or you can say a cake portion of the circle. Then this part is known as sector. This is sector, and I can call this one as arc, sector arc. Okay, arc. Then let this be the center of the circle. Then what will be area of the sector? Area of the sector is, here you can see a small angle is here, this angle. Okay, now let me rub off this one. This is sector portion. This angle is known as central angle. This is central angle. So here we have the sector area. Area of circle is equal to pi r square. Then area of sector is equal to central angle by 360 degree into pi r square. Then we have we have this sector portion and this arc length. Okay, this is the arc length of the sector. Yes, children, now here we have the diameter of the circle. This is the diameter of the circle. So if you consider this diameter of the circle, then I can say there are two semicircles here. This diameter, it will divide the circle into two equal halves. So this is one semicircle and this is another semicircle. See, like this portion. This is one semicircle and the below one is another semicircle. Now what is the angle made by a semicircle? Again, I am drawing here the diameter. Okay, diameter, mark it as A, O, B. Now if I draw angles, if I draw an angle from the two ends of the diameters on the circle, see, like this. Okay, or if I want, I can draw here also, down. See, these are two angles, suppose X and Y. This is one angle, this is another angle. So here we can say the angle made by the semicircle or the angle made by the diameter on the circle is always 90 degree. These two angles are always 90 degree. Again, I am telling you, diameter of the circle AB, and A and B are the two ends of the diameters, and from these two ends of the diameters, if you draw any angle on the circle, wherever you draw this angle on the circle, that angle will be 90 degree. So I will show you the pattern. Like suppose, now let me just, I'm just tilting the diameter, okay, in another position, just for your understanding. See here, now this is the center. Okay, and now I'm going to draw the various angles from the two ends of the diameters. See, another one, another one here, other side also. Wherever you draw on the circle. Okay, now I'll just highlight that diameter portion. Okay, now you can see here my diameters are here, A and B. From this A and B, I made one angle on the circle, let it be C. Okay, now from this A and B, again I made another angle here, D, with this AB, another point here. Now with the same point A and B, points A and B on the other side of the circle, here may be X. Okay, again A and B, maybe this is Y and this is Z. You can see that all these angles made from the two ends of the diameters, they are all 90 degree. All angles. So I can write here angle. I'm going to write here now. Okay, angle ACB is equal to angle ADB is equal to angle EEB is equal to angle AXB is equal to angle AYB is equal to angle ZB is equal to 90 degree. That means the angles made by the semicircle is 90 degree, or angles made by the diameters on the circle are always 90 degree. Yes, student. Now coming on to another information about the circles. Just now I told you that if this is the diameter of the circle marked as A and B passing through the center, obviously, Okay, if any angle made by the two ends of the diameters on the circle, we know they are 90 degrees. So I'll just show you again. Point on the circle, another point on the circle, then another point on the circle again. See, here you can see these are all on the circle. So what did I say? Those angles made by the two ends of the diameters on the circle are always 90 degree. Okay, now coming to this circle, considering the same diameters AB. Okay, now if my angle made by the two ends of the diameters are outside the circle, I'll show you. If this, see, from this end and from this end, if you are getting an angle outside the circle like this, all are outside. Okay, you can see that all these four angles are outside the circle. Suppose this is A, B, C, D, E. Here coming to this one, F, G, H, I. Here you can see that as the angles, okay, as the angles here on the circle is 90 degree like this, and when it was stretched outward, it is stretched outward. For sure we know if this is 90 degree, when it is stretched outward, the angle gets decreased. Here also you can see when it was on the circle it was 90 degree, but then it was stretched like this. See, it was like this. When it was stretched like this, it became 90 degree. Coming to downward also, here like this, it was 90, it was completely 90 degree. When you just stretched outwards, the angle got decreased. So here I can say all these angles are less than 90 degree. This angle is also less than 90 degree. Okay, now coming to our third circle. Here, say considering the same diameter A, B and center O, if you are making an angle from the two ends of the diameters inside the circle, see, inside the circle, anywhere, yes, now I took just 4 points inside the circle. See, okay, there are 4 points here, A, B, C, D, E, F, G, H, I. Then I can consider this one as J, K, L and M. Okay, here you can see these angles, they are greater than 90 degree. All are greater than 90 degree. That means, see here children, that means first the angle was on the circle with 90 degree. What happens when you are just pulling it, pulling it inwards? Okay, pulling it inwards, it becomes greater than 90 degree. See here also this angle, it was 90 degree. Initially it was 90 degree. When you got stretched like this inwards, the angle got increased. Now coming to down also, suppose this was the point on the circle with a 90 degree. Now when you got stretched like this, it became, see, it was 90 degree on the circle. When it was stretched, the angle got increased more than 90 degree. So that means if an angle is made inside the circle from the two ends of the diameters, the angles are greater than 90 degree. If the angles are made on the circle from the two ends of the diameters, angles are always 90 degree. And if the angles are made again from the two ends of the diameters outside the circle like this, the angles are less than 90 degree. So here I can say on the circle, angle is 90 degree. Inside the circle, if the points are inside the circle, then the angles are always greater than 90 degree. And if the angles are outside, if the angles are outside the circle, then they are less than 90 degree. on the circle 90 degree. Inside, if the points are inside the circle, angles are always greater than 90 degree, and if the points are outside the circle, they are always less than 90 degree. Yes children, if you find this video useful, please do share, subscribe and press on the bell icon for getting the notifications. Very soon I will be uploading the next video. Thank you.